Hi all. In last video, we discussed about identities in trigonometric functions and as inverse trigonometric functions. Today we will discuss about the important problems from the chapter inverse trigonometric functions. Here is the first question. We need to find the principal value of tan inverse sine of minus pi by 2. Here tan inverse sine of minus pi by 2 is given. So first we need to find sine of minus pi by 2. Then we substitute that answer here. Then we need to find tan inverse sine of minus pi by 2. But we know that sine of minus x is minus sine x. Also sine pi by 2. The value of sine pi by 2 is 1. Then what is sine of minus pi by 2? Sine of minus pi by 2 is here minus side we can take outside. Then sine of minus pi by 2 equal to minus sine pi by 2. What is sine pi by 2? It is 1. So this is equal to minus 1. That is sine of minus pi by 2 is minus 1. Now we just substitute sine of minus pi by 2 as minus 1. That is tan inverse sine of minus pi by 2 equal to tan inverse minus 1. Now the identity tan inverse minus x is minus tan inverse x. Also the value of tan pi by 4 is 1. Then if tan pi by 4 is 1, what is tan inverse 1? Tan inverse 1 is pi by 4. We just substitute these identities here. Tan inverse minus 1 is just taking minus outside with this identity minus tan inverse 1. But tan inverse 1 is pi by 4. So this is equal to minus pi by 4. That is tan inverse sine minus pi by 2 is minus pi by 4. We apply these four identities here. This is another question. We need to find the principal value of cos inverse cos 680 degree. Here cos 680 degree we need to find. Then we substitute that value here. Then we reach to the answer. Here cos 680 degree is given. We know the identity. Cos 2 pi minus theta is cos theta. So we write cos 680. Here 680 we rewrite as 2 into 360 minus 40. So cos 680 is cos 2 into 360 minus 40. But we know cos 2 pi minus theta is cos theta. Then cos 2 into 360 minus 40 is 40. Here we substitute these values. That is cos inverse cos 680 is instead of 680 we write this. Then cos inverse cos 2 pi minus theta is cos theta. So instead of this value we write cos 40. But what is cos inverse cos? Cos inverse cos theta is theta. That is cos inverse cos 40 is 40. So the principal value of cos inverse cos 680 is 40. Here the third question is we need to find the value of cos inverse minus 1 by 2 plus 2 into sin inverse 1 by 2. First we can find cos inverse minus 1 by 2. Then we find sin inverse 1 by 2. Then we substitute that values here and we will reach to the conclusion. Here cos inverse minus 1 by 2 is given. So we apply the identity cos inverse minus x equal to pi minus cos inverse x. Here x lies between minus 1 and 1. Also We know cos pi by 3 is 1 by 2. Sin pi by 6 is 1 by 2. We discussed about these identities in our previous video. We apply these identities here. Cos inverse minus 1 by 2 equal to pi minus cos inverse 1 by 2 with this identity. Instead of x, here it is given as 1 by 2, which is equal to cos inverse 1, cos pi by 3 is 1 by 2. So what is cos inverse 1 by 2? Cos inverse 1 by 2 is pi by 3. So we substitute pi by 3 instead of cos inverse 1 by 2. That is, this is equal to pi minus pi by 3. Now just cross multiply 3 into pi minus pi by 3. That is 3 pi minus pi, which is equal to 2 pi by 3. Also, sine inverse 1 by 2. Here sine pi by 6 is 1 by 2. So sine inverse 1 by 2 is pi by 6. We get cos inverse minus 1 by 2 and sine inverse 1 by 2. Next, we substitute these values in our given question, which is equal to cos inverse minus 1 by 2 is 2 pi by 3 plus 2 into sine inverse 1 by 2 is pi by 6. So we substitute that. Now just cancelling and adding. Here 2 and 6 are cancelled. Also the denominators are same, so we can add the numerator. 2 pi plus pi is 3 pi by 3, which is equal to pi. So the value of this quantity is pi. The fourth question is, we need to prove that tan inverse 1 by 2 plus tan inverse 2 by 11 equal to tan inverse 3 by 4. Here, which identity we need to apply? Tan inverse x plus tan inverse y is given. So the identity we apply here is tan inverse x plus tan inverse y is tan inverse x plus y by 1 minus xy. So instead of x, here it is 1 by 2, and instead of y, here it is 2 by 11. So we just substitute these values here. Tan inverse x plus tan inverse y equal to tan inverse, instead of x, we put 1 by 2, and instead of y, we put 2 by 11. Here denominator 1 minus xy is substituted. Now just cross multiplying and cancelling. Here 1 into 11 is 11 plus 2 into 2 is 4 by 2 into 11 is equal to 22, and 11 plus 4 is 15. So 1 by 2 plus 2 by 11 is 15 by 22. Similarly, 1 minus 1 by 2 into 2 by 11 is calculated. Here multiplication is given, so we can just multiply the numerator and the denominator. Also by subtracting, we get the answer as 20 by 22. Here we substitute 15 by 22 instead of this numerator and 20 by 22 instead of this denominator. Also 1 by 22 and 1 by 22 is in both numerator and denominator. So we can cancel, and the answer is tan inverse 15 by 20. Or we can just simplify. Here 5 3s are 15 and 5 4s are 20. So by cancelling, tan inverse 3 by 4. That is, we reach to this RHS. That is, tan inverse 1 by 2 plus tan inverse 2 by 11 is tan inverse 3 by 4. We proved the LHS equal to RHS. We start from LHS and we reach to the RHS. Here is the fifth and last problem. If tan inverse x plus tan inverse y is pi by 4, here product of x and y is less than 1, then we need to find the value of x plus y plus xy. Here also we apply the same identity. Tan inverse x plus tan inverse y equal to tan inverse x plus y by 1 minus xy. Here Tan inverse x plus tan inverse y is pi by 4. It is given. So this is equal to pi by 4. That is tan inverse x plus y by 1 minus xy is pi by 4. Here just equating the RHS we get like this. Then tan inverse x plus y by 1 minus xy is pi by 4. So what is tan pi by 4? Just moving this to RHS we get x plus y by 1 minus xy. But we know that the value of tan pi by 4 is 1. So what is here? Just substituting 1 instead of tan pi by 4. So x plus y by 1 minus xy is 1. Now just cross multiplying x plus y equal to 1 minus xy. We just move to here, which is equal to 1 into 1 minus 1 into xy. That is equal to 1 minus xy. Or we can just move minus xy to LHS. That is x plus y plus xy equal to 1. Here we need to find the value of x plus y plus xy, and we accidentally get like this, x plus y plus xy equal to 1. So we find the answer. Thank you all.